So I'm going to get started. It's 7:30. First of all, thank you so much for coming. I'm so excited about tonight. My name is Beth Benzing, and I am from Strathaven. I teach at Strathaven High School. And what's really cool about tonight is that you guys are from all over the Philadelphia region. So if you don't mind, take a minute, please, and write in the chat where your school and maybe where it is, like near King of Prussia Mall or, in Delaware County, and then your school mascot. If you could add that in the chat and we can see where everyone's from, that would be great. Go ahead and do that in the chat.
Are people able to chat? Because haven't seen.
That's what I'm thinking.
Oh, there we go. Yeah, they are.
We
Perfect.
got a few.
Peter wins.
I'm typing mine in too.
Welcome. Me too. I think I'll do the same.
I was just at Upper Dublin yesterday for a track meet. Wait, which of my kids is here? I see someone just. Whoever iPhone is, I don't know who you are, but make sure you tell me you were here tomorrow for credit. Jack tags.
Okay. I get a lot of analytics on these meetings too.
So.
Awesome. I love it. Wow. Actually, from all over the regions. And some actually signed up from New Jersey, which is just awesome. So tonight we actually are going to have 3 presenters. And the first one is Leigh Nataro from Moravian University. Leigh, take it over.
Okay. Sounds good. So we are going to be having 3 main sessions this evening during the hour that we're here. We're going to talk a little bit about multiple choice strategies for the AP Stat exam. We're going to talk about sampling and experiments because that can be a little bit challenging for people. And we're also going to talk about probability. And we'll have some time at the end for Q&A. And I already had somebody ask me in the chat, is this covering the entire course content? And I think that'd be really hard to cover all 9 units in an hour, but we're going to cover some main ideas that we think will help you to be more successful on May the 4th. So just a reminder about the multiple choice questions. I'm guessing you already know this. There are 40 questions and you have 90 minutes. So that's about 2 minutes per question. And there are 5 answer choices. And in my experience, as I've looked through full exams, the ones at the beginning are a little bit easier and the ones at the end are a little bit more challenging in general. And it's really important to know that there's no penalty for guessing, so you don't want to leave any blank. That being said, you don't want to randomly guess at one answer. You want to have some good strategies to help you attack those multiple choice questions. And so we're going to take a look at several different strategies. One of the strategies that we're going to take a look at is something known as Annotate the Question. Another one we have is Annotate the Answers, and you would do this first before actually looking at the stem of the question. We're going to talk about a strategy called Scratch One, Choose One of my personal favorites. And then we'll take a look at how you could combine all these strategies together in answering a multiple choice question. So let's talk about strategy number 1, Annotate the Question. So you might do this by writing numbers in the margin and labeling them. For example, something might be X bar, and you might write that in the margin with a label. You might actually underline the question, or you might circle key words. So let's take a look at how this might work in an actual question. And this is where you're going to get a chance to participate in the chat. So here's a question that we're taking a look at. And I'm going to read you the question, and I want you to think about what words or numbers you might circle or underline. Okay, so studies have shown that approximately 10% of the US population is left-handed. A research study selects a random sample of 40 people in the US and asks a number of questions about their lifestyle. Which of the following shows the probability that exactly 5 of those in the survey report that they are left-handed? So if you're going to annotate this question, what is something that you might circle or underline? Go ahead and give me some answers in the chat. Based on this, yeah, 10%, definitely. Oh, random sample of 40, yeah, recognizing the sample size. All right, so let's see what I thought here. And exactly 5. Oh, I think you guys must have been like viewing my slideshow earlier. So identifying the 10 and 40 are key, and what 10 and 40 represent. A lot of you even put P equals 0.10 in the chat. Our sample size is 40. And then another thing that you might make a note of is the fact that this is a binomial situation. And I know you're not used to annotating questions, but why might this be a good idea? So let's say that you worked through the question, you know it's binomial, you're confident about what P and N are, but for some reason you're not getting one of the actual answers. The fact that you've written all this down on the question itself means that when you go back to try this question later, you'll be able to get back into that question easier because you've left yourself some notes. So let's take a look at another strategy. This one is called Annotate the Answers First. And it might seem strange to the fact that you might want to review the answers first, but there are cases where that might be helpful. And this will help you know then what to look for within the actual prompt. So let's take a look at how to use this strategy. So these are the answers to a question, right? These are the answers to a question. I don't have the actual few sentences that were above this question, but here's the question and the answers. We're going to annotate these answers. Assuming the conditions for inference have been met, what procedure should be used to determine if more than 20% of customers will redeem their K-cash within the longer time frame? So here's some things that we might think about with this one. We might think about the fact that these are all different procedures. These are all different procedures for doing significance tests. And you might even notice that for some of them, it has one sample, and for others, it has two samples. So one of the questions we might ask ourselves is, do we have one sample or two? And you might be like, I'm not really sure yet. Don't worry, we're going to go and look at the actual question after we've annotated the answer. Notice also that there is two of them, answer choices A and C, that have a mean, and there's two of them that have proportions. So are we working with means or proportions? Based on the fact that it's got 20% here, you might be thinking about proportions. And then last but not least, if we have a chi-squared test here, we might be looking for a two-way table within the question. So I'm going to give you a moment to read what was above these answers. So here's a scenario. In the past, 20% of customers returned to the department store K to redeem their K-cash. If given 2 weeks to redeem their K-cash, I see a spelling error there, K-cash, instead of 1 week, will the proportion of customers who redeem their K-cash increase? 250 randomly selected customers were given 2 weeks, and 80 of them redeemed their K-cash. And then this was the question we saw before. Assuming the conditions for inference have been met, what procedure should be used to determine if more than 20% of customers will redeem their K-cash within the longer time frame? So for a moment, think about those questions that we had where we annotated the answers. Are we talking about one sample or two? Are we talking about means or proportions? And are we talking about chi-square test of homogeneity? Do we have a two-way table, which obviously we don't? So let's get some more questions in the chat here. So how do we feel about the two-way table? Definitely not a two-way table, right? Definitely not a two-way table. What about one sample or two? In the chat, give me the number either 1 or 2. Yep, it was one sample, and the sample size, you might not have noticed the sample size, but the sample size was 250. So definitely one sample. And then, are we working with means or proportions? In the chat right now, means or proportions? Which one do we got? Oh, proportions. You guys are rock stars here. Yes, it is proportions. And so the correct answer for this is B. It's a one sample z-test for a proportion. I feel like you're anticipating my questions. All right, let's take a look at strategy number 3. Scratch one, choose one. So this strategy is really helpful if the answers have something that's similar in many ways and maybe different in one or two little ways. So looking at how the answer choices are alike and how they are different. This way you can easily eliminate 2 or 3 answers, and that means that you've increased the probability that you'll get the right answer if you have to guess in the end, because remember, there is no penalty for guessing. So let's take a look at how we would apply this strategy. Here's the scenario. So to determine the proportion of trees that are infested with the spotted lanternfly in one region, there was a 99% confidence interval that was constructed. It was estimated that there are 250,000 trees in the region. That would be the population. And there's a random sample of 500 trees that are inspected for that spotted lanternfly. And it was determined that 120 trees were infested. So based on this study, which expression could be used to create the 99% confidence interval? So we're talking about a 99% confidence interval for a proportion. And here are the different answer choices. So remember, scratch one, choose one. We want to take a look at how the answers are alike and how they are different. Notice all of these answer choices start with 0.24, which means we don't have to worry about that part of the answer. That's our sample proportion. That was p hat, right? That's not where those answers differ. Where they differ is in the critical value. So if we can remember which critical value corresponds to a 99% confidence interval for a proportion, then we're in good shape. And I would say, even if you're not really sure how to figure that out, remember that if you have a higher level of confidence, you're going to have a wider interval. So that means that we want the bigger of these values, which is 2.576. So notice right away, we've eliminated two other answer choices. By the way, in the chat right now, the 1.96 value, do you know what level of confidence that's associated with? 1.96 for a critical value. What level of confidence? All right. And yes, I saw somebody ask about using the normal CDF command on a calculator. You can do that to figure out those critical values, or you can even use the T table with the infinite degrees of freedom row, in case you were never knew that. A fun fact there. So now we have answer choices A, B, C, and D. And we might remember that the sample size should be in the denominator. And notice our sample size is 500. So that's going to eliminate answer choice B. And at this point, if you had to guess, if you're running out of time, you have a 50-50 chance. However, I would recommend looking at the formula sheet and recognizing that in the numerator, we want the sample proportion, and the sample proportion was 0.24. So the correct answer for that is A. All right, I believe we have time for one more here. All right, so these were the strategies that we had. We're going to look at an example where we're going to combine these strategies. Annotate the question, annotate the answers first, and scratch one, choose one. All right, now we're annotating the answers first here. And one thing I want to point out is a lot of times the answers will, especially when they're sentences, have parallel structures to them. Notice we're being asked to interpret the slope. And notice that these all start off with for each additional 1 centimeter increase. All right, they all start off that way, but then they kind of diverge a little bit. Some of them later on have the word increase, some of them have the word decrease, and they have different values. But this is what you could highlight or annotate when you annotate the answers first. So we're going to take a look at the actual prompt, the computer output that came with this question. All right, and actually, let me go back here. We're thinking the slope is either 97.8 or 1.654. So when I take a look at this computer output, which number is our slope? Go ahead and give me a number in the chat. Is our slope the 97.8 or the 1.654? It is the 1.654. Yeah, the 97.8 is actually the y-intercept, right? So that's going to help us then with our scratch one, choose one, because we can eliminate some of the answers, right? Our slope was positive, so it doesn't make sense to have answer choices C or E with the words decrease there, right? Because that would indicate the slope was negative, and we know the slope was positive. We can also eliminate answer choice A because we know that 97.8 was the y-intercept. So right away, if we were running out of time, we've narrowed it down to answer choices B and D. So let's just focus on answer choices B and D by themselves for a moment and see if we can figure out the difference between these. Notice that, let's see, I might have to go back a screen or two. Let me go back 1 or 2 screens here. Y was the height and the femur length was X. So it looks like we're using femur length to predict height. So let's move on here and think about the fact that slope is change in Y over change in X. So we're talking about a change in height over change in femur length. And the change in the slope was 1.654. So we're talking about a prediction of 1.654 centimeters taller in height for every 1 centimeter longer in femur length. And so that means our correct answer for this one is D. So just remember your multiple choice strategies as you're working through the questions, annotating the question, annotating the answers first, scratch one, choose one, or combining all the strategies. And don't forget that you always do want to make your best educated guess for every question. Or actually, hopefully you're not guessing, but if you do have to guess, make it a best educated guess. And I'm going to stop screen sharing and now turn this over to Bob Lochel.
Thank you, Leigh. Friends in the chat, can we get 2 claps for Ms. Nataro and her presentation? As I get myself all set up to go here.
And while he's getting himself set up, I know some people had sent me some direct message chats. I will try to answer those during Bob's presentation.
Okay. Leigh, is my screen on there? Am I good?
Yep,
now?
you're good.
Thank you very much. Yeah, I did see, I saw something in chat about the recording. This is being recorded. I suppose we hadn't planned on this. I suppose we can send out an email afterwards that says where the recording lives. And by the weekend, that should be there. Does that seem reasonable to my other 2 co-hosts here? Yeah, I think that would work, right? Okay.
I think to all the emails that were registered is who, right?
Perfect. Yeah. And by the weekend, I should have that up and running on YouTube somewhere. Perfect. So friends, this part is going to be about sampling and experimental design. And I do want to explain the picture is that you may not be aware that we have many teachers in the Philadelphia area who are actually AP readers and help to grade the papers. And before the pandemic, a whole bunch of us met, and like people do in Kansas City, we all met for barbecue. And this is just one picture of all the Philadelphia area people that happened to be there that day and joined us. So just know that there's a large community of statistics, teachers, and professors around, all to support you. So this section is about sampling and experimental design. I teach at Hatboro-Horsham High School. And what we're going to talk about here are many of the terms and ideas that are somewhat sticky for students when thinking about sampling and experimental design on the exam. I'm going to give some examples here. There will be some multiple choice opportunity in the chat. And come along with me. So we're going to dive right into a question here. Here's a question about student fees. Administrators at Villanova University are considering raising the student activity fee in order to pay for improvements to other athletic facilities. And in order to keep costs low, they plan to conduct a convenience sample. That sounds bad. At the next basketball game. The first 50 students who enter the stadium could make up the sample. So here is the question. Why might such a sampling method be biased in producing an estimate of the proportion of students who support raising the student activity fee? There's a lot going on in this question. And just like with Mrs. Nataro, I suspect that you want to take this question and break it down. But something that's interesting to me is, and important to me, is that our goal is to produce an estimate. Our job in this problem is to estimate the proportion of students who might support this. And your job as a student is to tell me what could go wrong here. Invest yourself in the actual situation. We've actually are being paid to do this survey for Villanova University. We want to produce an estimate. Think about things that could go wrong. So here comes our first opportunity for multiple choice. We're going to call this choose the best. So again, why might such a sampling method be biased in producing an estimate of the proportion of students who support raising the student activity fee? So here come all 4. And before I show all 4 of these, keep in mind, these are not fully fleshed out solutions because the solution to this is actually a couple sentences long, but which one of these gets to the essence of what we should be thinking? So is it A, not all students like basketball? B, the sample size isn't big enough. C, the students in the sample may be different than other students. Or D, only a random sample can give accurate information. In chat, please. Which one do you like? Okay, looking through. See a lot of C's. I see a few D's. And I'll say only a random sample can give accurate information. I would say a random sample would be ideal for giving great information. There are other ways to give good information. A random sample would really be awesome. But keep in mind, that doesn't tell me what's specifically wrong with the sampling method that I'm choosing. So when we choose D, we're kind of going off course a little bit. Focus at what we've been given and tell me what's wrong with that convenient sample, because maybe that convenient sample is pretty good. And there may be circumstances where a convenient sample might actually be an appropriate measure. In most cases, it's not, but it could be. So in case what we're looking for here is the students in the sample may be different than other students. And I saw some people annotate their answer to say something like the sample is not representative of the population. That's true. So let's go down that path a little bit. How is this sample different from the population, perhaps? So how should we approach this task? First of all, when we say the word biased, what does it mean to have a biased estimate? Why is our sampling method biased? And just what are we trying to estimate anyway? So before I give you the model solution here, some ideas to think about when you write solutions like this. First of all, the essence of statistics. This is something I show in all of my classes. My students write it at some point. Are you ready for it? Here's one picture which tells you the essence of statistics. Here it is. Boom. That's it. We want samples that give us information about populations. And the sampling methods that we use will either do a great job here and hit the target or miss the target. How good of a job will our sample do to represent the population? And that word bias, sometimes students have a misconception as to what it means. Bias means that somehow the design of our study systematically favors certain outcomes. So how does our sample systematically favor certain outcomes? So some pro tips here. First of all, whenever you talk about bias, please, the word overestimate or underestimate should be sniffing around your response. If a statistic is biased, somehow it's missing the target. Tell me how it's missing the target. Context, context, context. What is this problem about? Make sure you're including what the problem is about. This one is about a survey to increase the student activity fee. I need to hear you talk about the student activity fee. Be careful of using fancy language carefully. Some students think that if you just write a whole bunch of statistical words and sentences that somehow we will take out the right pieces and you'll be deemed correct. I'll tell you, in many cases, you can give a very elegant solution, a response to an AP statistics problem without using fancy language. And then finally, stay on point, don't ramble. In my class, I call this word salad. Please avoid word salad. Stay on point with the question. So what does an ideal solution look like here? A model solution. Well, this one actually has many parts. So the 50 students may not represent the student population as a whole. It'd be nice to know why. Well, perhaps these students have more school spirit than the average student. They're going to the basketball game. That's how they might be different. That word different is going to show up a lot in this talk tonight. Therefore, those students might be more likely to support an increase in the student activity fee. So we recognize the difference, what the consequence of that might be. And now we're going to talk about bias, in which case the administrators may overestimate the proportion of all Villanova students who might support an increase in the student activity fee. Now, that's a long solution. It hits all the main points about bias and overestimation. And keep in mind, it's all about the context. What's different about these students and how will that influence the student activity fee? So make sure you're staying with context. Let's continue on with this problem. We have a new survey now. Because of the large number of students at the university, a second method the administrator is considering consists of using a computer with a random number generator to select a simple random sample of 500 students from a list of 2,000 student names. Describe how to implement such a method. So just very briefly, randomization methods. These do come up often in AP Stat. There's a couple ways to randomize. This particular question does say that we're going to use a computer with a random number generator, but just to make sure we go over all the things we might need, let's talk about all the ways you could randomize. One's the famous hat method. We put slips of paper in a hat without replacement. We shake up the hat. That's the randomization. We draw slips of paper and we stop after we get to 500 students. The one thing I will say about this one is if you choose this method, you may not need to number the students. If you have all of the students on a slip, on a piece of paper, a big spreadsheet somehow, and you print them out, you can just snip out all the student names and put them in a hat. If you number the students, then you later have to come back and say, we will find those students with those numbers. Well, you can just put the names in the hat if you wanted to. But we're asked to use technology. That tends to be the method in AP statistics. Technology, define your domain. We will number the students from 1 to 20,000. Each student gets a unique number. We will draw 500 unique numbers, meaning no repeats, and we will stop when we have 500 students. The last one I'll talk about very briefly, the table of random digits. Back in the old days, table of random digits were kind of a big deal. We prefer not to use them, yuck. But if a table of random digits is given to you, know how that you can mark off the table to show different students who are selected. But you'd have the same type of thing. Number the students, tell me the stopping rule. Okay, here comes another choose the best. New scenario. Another administrator suggests that perhaps stratification by type of student, undergraduate versus graduate, older students versus younger students, essentially, may provide a more precise estimate of the student of support of the activity fee. Under what circumstances could stratification by type of students provide a more precise estimate than a simple random sample? Essentially, why should we stratify? All right, here come your choices. If we want to make sure that everyone has a chance to participate, if we think that everyone will disagree with the activity fee, if we want our results to be more accurate, if we think undergrad and grad students may feel differently, please respond in the chat. Which one do you like? Love it, love it, love it. We got rock star status here. Yes, D is wonderful. Notice that word different has shown up again. If undergrad and grad students might feel differently, then we should stratify. And we're going to talk about what stratify is, but let's address some of these other responses here. C is one that struggling students might write. If we want the results to be more accurate, what does that mean to be more accurate? You have to tell me a little bit more about that. A, if we want to make sure that everyone has a chance to participate, that's true. But if all of these students feel the same, we really don't need to stratify. The reason we stratify is because we think that the older students and the younger students might have differences of opinions, and we want to include them equally within our survey. So it's that key phrase about differently that we want to talk about here. Okay, so more about stratifying. If we believe there's a difference in opinion on raising the student activity fee, then stratifying by type of student is appropriate. And that applies to anything we do within a survey. If we think that freshmen and sophomores and juniors and seniors may have different opinions on having parking fees, then you want to stratify by grade to make sure every grade has proportional representation. Take an SRS from each group, proportional to the total size. Okay, so that's all about sampling. That's my Villanova question about sampling. Now we're going to switch gears to experimental design, which has another set of vocabulary words associated with it. Fun in the sun. So a producer of a famous brand of sunscreen plans to conduct an experiment to compare a new sunscreen formula to the current method. Your outward appearance is not changed by either method. Company recruits 100 volunteers to participate in an experiment on a sunny day in Ocean City, New Jersey, where participants will be asked to spend 2 hours having fun in the sun, after which subjects' arms will be assessed. I don't know if I want to do all of these. Let's see if we can do them real quick because I'm looking at the clock. I think we're okay. What are the experimental units? Go ahead and put that in chat. And I'm bringing this one up because in recent years in the AP Stat exam, we're finding more questions like this where you're asked to identify parts of the experimental design. So again, what are the experimental units here? Please, we'll just take a couple things in chat. What are the experimental units? Yeah, notice this one's a little bit tougher. We've got more questions here. Yeah, these are kind of tricky. Okay. What are the treatments? What's the response variable? So let's take a look here. The experimental units are the 100 volunteers. And I'm actually going to embellish this one a little bit. Last year in the exam, there was a question about twins, and they were giving twins acne medication. And I think the number was 72. It doesn't matter what the number was, but there were 72 sets of twins. And the experimental units, what they expected you to say was each of the twins. You had to identify that there were a total of 144 people, each twin. If you said sets of twins, that was no good. The individuals that are receiving the treatment are the experimental units. And they don't have to be people. They could be things as well. But the individual items or people receiving the treatments are the experimental units. And here they are the 100 volunteers. Treatments, I already gave it away. New and current sunscreen. For the sake of time, I'll just blitz through these. They're the new and the current sunscreen. Actually, this next one I'll ask you to put in chat too, because this could be sticky. What do you think is the response variable? If I go backwards to my previous screen, what is the response variable in the chat? What's the response variable? This was a little bit trickier. Thank you for those who are going off on a limb and talking about these things. So keep in mind, response variable is the thing that we are measuring. What is it we're measuring within the experimental units? So we gave people sunscreen. Response variable is the amount and hopefully the change of, I said skin darkness here, how much sunburn there is. What is the thing that we're measuring? That is the response variable. So something like I see the effect on arms, the arms, it's really the amount of skin darkness, something that has happened. What is it we're going to measure? The amount of sunburn on the arms, the difference in sunburn, something that we're measuring about the arms. So make sure we're clear on what the response variable is. That might be very helpful because I saw a lot of different responses there in the chat, but very good responses. Pro tips, experimental design. If you were asked to design an experiment, there's a few things that you do need to consider. We haven't seen a question about just design an experiment for many years, but it's worth going over all the pieces. You need to have randomization, assignment to treatments, a clear description of what the treatments are, measuring and comparing some response, and make sure you're talking about context. Say something like compare results is never going to fly. Compare the amount of sunscreen. That would be okay. Compare results is never going to be sufficient enough to talk about the response variable. Okay. Let's go back to fun in the sun. Randomize subjects to treatments. How might we randomize a subject to treatments? Well, we have two treatments here. We can just flip a coin. Heads, you get the old formula. Tails, you get the new formula. And they're applied, I think we set the arms, but whatever they tell us to do, that's fine. And after 2 hours, measure the extent of sun exposure to the arms. So this would be a nice description of a experimental design. Could we use a placebo? And should we use a placebo? Well, we could. I wasn't going to put that one in chat. Let's do that one in chat real quick. Should we use a placebo? What do you think? I think I gave it away already. Should we use a placebo, folks? Nah. Thank you for the nah. Oh. Well, let's do this. I see some no and I see some yes. If someone can real quickly type a compelling reason about why we could or should use a placebo. Could we use a placebo here? Oh, there's some interesting things going on here. Okay. So keep in mind, I'm going to go way back to the beginning of the problem here. Okay. Producer of a famous brand of sunscreen plans to conduct an experiment to compare a new sunscreen formula to the current method. So they want to compare new to current. Could you use a placebo? So let's talk about that. Could and should. Those are two separate questions here. You know what? I don't have placebo on my next screen. We'll just save that for a minute. We could use a placebo if we gave people another treatment that looked and felt like the new or the current sunscreen. Maybe you give it in a bottle that is unmarked. We tell it to put it in their arms. So you could have a placebo here and have them go about doing their daily business. We could also have a different conversation about whether that's ethical, because we now know that we're giving people something that really isn't going to protect their arms here and potentially might burn them. So you could. Should might be a different question here. Right, exactly what Peter was saying. We're comparing between the two. So the question said we're comparing between the two, but we could add a third, that is a placebo. Okay, let's move on to something else. Could we improve on this design? And I already went a little too quick, and maybe you saw the next part here. Could we improve this design? We could. We could do match pairs. So the piece of advice I would give you here is, if an experiment can be done match pairs, and not all can be done match pairs, you should try to use match pairs. And that's what happened last year in the acne formula question. The match pairs, the procedure would be each experimental unit serves as its own control group. You get both treatments or create pairs of self-similar blocks. Well, I haven't given it away yet. Can someone explain in chat, how would we implement match pairs in this setting? How would that work? Thank you, Tom. Tom's got it. He had it all set to go. Yeah, you got two arms. So the idea might be here. Oh, first of all, wide helps reduce the variation among the experimental units. Improved design, subjects flip a coin. If you flip heads, you get the old on the left arm, the new on the right arm. And again, I probably have bottles that are not labeled with new and old. They just put it on their arms, but somehow we know which is which. And tails, old, new, right. Then we can compare each of the units. We can compare you to yourself. And we can look to see which arm has become more burned when you had fun in the sun. and compare difference in exposure between the arms, new versus old. Okay. Blinding. Should we blind? Could we blind? We could. Could the sunscreen experiment be double blind? It could be. Let's go through what that might be. If neither those using the sunscreen or those evaluating the sun exposure know who received which treatment, the experiment could be double blind. And let's go through both of those people, both of those ideas here. Those using the sunscreen. Well, if I give you the sunscreen in an unlabeled bottle, or maybe it has some kind of a code that I scan on it, which is oftentimes how these are done, and I just give you the bottle, you don't know which one you got. You're just told to put the things on both arms. So you don't know which kind you have. And the people evaluating, now let's make sure we're clear about that, is not the person handing you the bottle, it's the person who later looks at your arms. They might think of you as patient number 15, and they're looking at your two arms and they're evaluating the difference, and they put it in a computer somewhere. So they don't need to know which one you have. They're just going to put the results in a computer somewhere, and we will compare the results that way. Because we don't want the person who's evaluating you saying, wow, that new sunscreen was really great. I'm even going to upgrade it a little bit more. So the person evaluating you really shouldn't know. And the purpose is reduces bias, changing behaviors from the subjects. Maybe if they knew they got the old sunscreen, maybe they're going to avoid the sun a little bit more, hide under an umbrella somewhere, react differently because they know they have that. Okay. One last, choose the best. A researcher suggests we improve the design by blocking by ethnicity. What would blocking mean? Here come your choices. Split the volunteers into ethnic groups, run separate experiments, ensure that ethnicities are equally represented in treatment groups, and randomly assign volunteers to ethnic groups. Did I have a D here? I'm afraid to click it because it might give it away. I don't have a D. Let's act like I don't have a D. A, B, or C, folks. What does blocking mean? Okay. I see mostly A's. That's good. That's what blocking means. Split the volunteers by ethnic groups, and then you run separate experiments. Blocking means you're going to do separate experiments. And the question often comes up about what's the difference between blocking and stratifying. Keep in mind, blocking in an experiment means I'm going to intentionally group these people separately and run separate experiments here and here. Stratifying means I want to have everyone within my survey and proportionally choose the right percentage from each group to participate in the survey, but there's only one survey. So it seems like the same idea. We're splitting things up somehow because we think there's differences. So blocking. How can we improve the design by blocking? Well, first of all, a block is a group of experimental units that are known before the experiment to be similar in some way that's expected to affect the response to the treatments. We might block. Am I okay? I see Kate just said I cut out briefly. Give me a thumbs up if you still got me, folks. Thank you, Leigh. So blocking means we think that ethnicity might have an influence on the sunscreen. So therefore, we're going to split them up and run separate experiments. And what we might find is the sunscreen works great for this group, but not so great for this group. Oftentimes in drug studies, you see the same things. We might block by age. Older people above age 60, younger people below age 50, look at the two groups and see the efficacy in both groups. Gender, age, ethnicity, those are the different things you might block by, and you might sketch this out. We might do by younger and older people, and within each group we want to randomly assign which one they get, and we're going to compare sun exposure differences within each of the experiments. And maybe we reach a different conclusion for younger people than for older people. Okay. And at that point, that is all about stratifying in experiments, a whirlwind tour, and I hope you found it helpful. And now go forth, and as the count says, go get that 5 friends. Thank you for your time. And now I'm handing you off to the queen of probability, Mrs. Beth Benzing from Strathaven High School.
Thank you, Bob. I was going to try to find my sunglasses for you. That was great.
Don't wear them at night.
So fun. What I really like about your topic, though, Bob, is that I'm picking a topic just like you did that sort of happened a while ago, probably several months ago for some of you. So we sort of tried to strategically say what can best benefit you all the few weeks before to best set you up for the most success. And that's where I am right now. In fact, I'm going to share my screen.
Oops. Just letting you know, we see you fine.
Thank you. Okay, I'm going to select the topic of probability. Why? Because sort of like Bob, it's like these topics that, or Mr. Lochel is sharing with you topics that came up a while ago. I feel like probability has, but for me, anytime, there's been many probability questions through the years where my palms get all sweaty. And I'm like, oh, it's like just my nemesis. I'm like, oh, this is like, where do I get started? Truly, I do feel like it's my Darth Vader. It is my Lord. It's my Voldemort. It's just, the probability questions. Here we go. So today, my goal is to provide to you some type of toolbox of what do you do if you get a challenging probability question. And that's what I would like us trying to focus on. We're going to pick 3 questions today that I would like to go through with you, that I'm going to share with you sort of a breadth of a lot of different scenarios that could exist in a probability situation. The probability questions are going to be question number 3 or 4. So anytime, once you go through the free response questions, they're going to be right after you go through that number 1 in the beginning units. Right, the next couple questions will be one of your probability questions, and it's fun to get it. So let's see what we have here. Let's start with our first question. Take a minute and read this to yourself on your own. So this may or may not be intimidating for you, but let's start with what we know. So I always like to read and just write down what I read. Just simply write down what I read. And when I read through this, I saw there's 2 scenarios. Hopefully you saw that you can go take a bus to work or you can walk to work. And in this case, you can walk to work and it's take a bus to work. It's take an average of 12 minutes, standard deviation 4. So on average 4 minutes in either direction from 12 minutes. And 16 minutes to walk to work. So the question then, I always like to repeat, and I always have to reread that last question. Like, what is the point of this question again? And that is to find what's the probability that the bus will be faster than walking. So faster means you get there sooner, meaning shorter amount of time. Okay, so here's my question to you. And go slow through this, but I want you to think about right now, what do you think the reader needs to see? Even if you don't even know the answer, I want you to think through what would you have to provide to the reader if you attack this question? So actually, I don't see my chat. Give me a second here and find my chat here. There it is. Okay, so what do you think you would provide to this reader? What would we need to show? Any ideas? If you like to put it in the chat, you can. It's been a while, right? I like what some of you are sharing. You're saying, I should start with a picture. That's probably a good start. I should start with a picture. What's important about your picture? If you don't know where to start, the first toolbox of, and no matter what, stat teacher you have, they're telling you, sketch an image, sketch a picture. And I love the normal curve. What should we name what should be important in our normal curve? I'll put my normal curve here. So what's in our normal curve? I went too far there. But you got to make a decision in this case. You got to make a decision. What do I want to do if I want to compare one time to another time? Like if it took me 12 minutes on a bus and 12 minutes on walking, what just happened? I made it a tie, right? But if it took me 12 minutes to get to travel on a bus and 10 minutes to walking, got there faster, right? So what did we do with the numbers 12 and what did I do with the number 10? Well, I have to compare them. So how do I compare these 2 numbers? I want to subtract. You're going to have to subtract the 2 numbers. Sometimes we want to compare and sometimes we want to compare, maybe add. In this case, to compare, we want to subtract the two values that could possibly happen. So in this case, we're going to look at all possible times of walking minus bus, all possible that could exist. And the key that some of you are trying to get at as in the chat there that you can see is we need to find our center of the distribution. This is really important for the reader to see, that you understand that the center of this distribution is 4. And then anyone know what if I push enter next? Yeah. We need to be able to find the standard deviation. The standard deviation when combining random variables, my instinct is this is going to come up this year. I don't know why. I feel like it hasn't come up in a while on a free response question and for a probability question. And in this case, it is the square root of sum of the variances. When you find all possible differences of times, you're going to square root and sum the variances to get that standard deviation of this distribution right here. And I think that's the key to this question, understanding this distribution. So even though, thank you for some of you taking that chance and saying, draw a bell curve, draw a normal curve. So try to find that center. In this case, I have the center as 4, but if you saw it as bus minus walk, your center would be -4, no problem. So our distribution is key. It's normally distributed, centered at 4, and the standard deviation is the square root of sum of the variances. Square root of, that's not super intuitive part of our course. The second problem I give is a really nice transition, but that's a lovely part that is sharing with you, describing the spread of that distribution. Okay, now we have to answer the question. What's the main point of this question here? What is the probability that the bus will be faster than walking? Well, let's think. If we were here at 4 minutes, maybe someone was at 14 minutes and 10, the walking would be 14 minutes and the bus would be at 10. I would put it, so that would be walking was slower, right? So it would take me a longer time to walk. So we're looking at anything greater than 0. Arriving at the exact same time, 12 minutes, would have a difference of 0. 10 minutes, difference of 0. So in this case, we want anything greater than 0. And then you're going to do the generic, which I'm hoping everyone is successful with once we get, the key is getting this picture right here, right? Understanding our spread, understanding our center. A couple of things that I've given this question before to classes. And when I do this, I just want to remind you, it's observed minus expected. I actually say this a lot in my class. Observed minus expected happens all the time. It's just not with z-scores. It's with residuals. It's with your chi-squared values, observed minus expected. And it's 0 minus 4, right? It's observed data is 0. That's a tie. We got there at the exact same time. Minus what should have happened. On average, you're 4 minutes apart from each other, divided by the standard deviation. Okay, let's get into my whole point of this question. And that was, what is important for the reader? When you're writing up a hard problem like this, don't forget, you need to share your thinking through the process. And what do you have to show them? In this case, you have to share the mean. Even if you don't, and then you have to share the standard deviation. If you can just understand that distribution, that's half credit. You're already earning and showing the reader you have strong knowledge of the situation. The next thing for this particular rubric and for this particular problem, you had to know what side to shade. And if you did the other direction of bus minus walk, no problem. You're going to be shading the other direction. Your center would be at -4. You would be shading left to 0. And then you actually didn't have to show all your work for the z-scores. Z-scores are always showing the reader, strong knowledge, strong understanding. But in this case, you really just needed the answer. So if you're not sure where to get started, start with that picture. You guys know that. Start with that picture and then try to think, what would be my center? What would be my spread? All right. How'd we do? That's number 1. I got 2 more. You guys ready? You have it in you? Did anyone check out the, I forgot, I didn't look because I was a little nervous in the beginning. I should go back. We should save our chat. I'll answer that question in a minute. Whoever just wrote that. Why do we shade the right? Love that question. Anyone have answer in the chat of why did, I have a lot of students who do this question, shade the left-hand side instead of the right. This is interesting. So let's focus on the last question here. Why is the probability that the bus will be faster than walking? Now, full disclosure, I have to like sort of put myself in the situation, just like was already shared earlier with our last two presenters. But, you know, I put myself on the bus. If it takes me 10 minutes, yeah, good advice from everyone who's sharing. But if it takes me 10 minutes, if 10 minutes, walking would be slower, that would be 11 minutes. So if I did 11, if you can see my arrow, 11 minus 10, 11 minus 10 is positive. So that would be right here. I would be 1 minute difference where walking would be a larger amount of time than running. I hope that helped. Okay, let's look at the next one. The next one I only want to spend 2 minutes on because my third question has a nice array of different types of problems within the problem. This one is very similar to my last question here, but I like it a lot, and I'm just trusting my instinct of what I would like you to make sure you're comfortable with as well. And this is in line with number one. I'll summarize the question for you. And this is, we want to convert temperatures of bath water from Celsius to Fahrenheit. It's as basic as that. That's the goal. So there's actually two questions. It wants to know, hey, what's the probability that the bath water will be between 90 degrees Fahrenheit and 100 degrees Fahrenheit? So in this particular question, it's most kids are going to get in fact, well, this is the question here. It's giving you what? It's always nice to look at what it's giving you. It's telling you, hey, all degrees in Celsius in this bathtub, this new bathtub that's on the market, is centered at 34 degrees Celsius, standard deviation 2. These are all my degrees Celsius. And now we want to convert these degrees in Celsius to Fahrenheit. So let's just make sure we understand. You guys know, how about who knows this one? If it's 0 degrees Celsius, could you guys convert that to Fahrenheit? 0 degrees Celsius is equivalent to what in Fahrenheit? Yes. Okay, so that's a conversion, right? That's something we've known for a while. 32 degrees is freezing. Hopefully bath water is not at 32 degrees, but that's a conversion. You all did that correctly. But so the first goal is to describe the distribution. So, that's another question in the chat. If it says describe the distribution, what should we be sharing to the reader? Describe the distribution. What do we want to share? Yeah. Yay. Awesome. Okay. So, yep, we got it. Center shape spread, I'm hearing. You're dead on. In fact, even most of you are going to get this first one, the mean. But the reason why I wanted to share this problem with you before I get to my third question today is because of my standard deviation. Be careful. This is guaranteed to be a free response. This is guaranteed to be a multiple choice question or a free response question. But when the spread of the data is being multiplied by a value, the spread will change. But when the spread of the data is adding, or when we're adding or subtracting, right? When we add or subtract the data, if we go to a 4-year reunion, all of our ages are just going to shift. The spread does not get fatter. So this is a really important aspect in terms of data spread that I don't want you forgetting about. And the reason why I wanted to bring this up. So I'm just going to highlight it right now. So center shape spread is our reminder, as you already shared with me. And you could do that. That's true, Tom. I just read your quote. You could do that for that question, except for this one, they actually want you to describe the distribution in Fahrenheit. So you would actually have to give the mean and the standard deviation. But you could have done that as well. Okay, so I think that's the key why I wanted to share that with you. The truth is, guys, I mean, this is great for this problem, but I have a feeling that several of you are going to be, owner, you're the president of a company or CFO of an organization, and you're going to have to make a tough decision at the end of the fiscal year. You're going to have to say, should I give all of my employees a 1% bonus, or should I give them a $250 bonus? And you're going to have this decision someday as a business owner, right? Well, keep in mind, if you do a $250 bonus as a business owner, all of the salaries of your company are going to shift. The spread will not shift. But if you give a 1% bonus, which would be nice, but if you give a 1% bonus, now the salaries of your employees are going to increase, but they're all still going to spread. So when you multiply, it spreads, adding and subtracting, it does nothing to the spread of the data. And then I think that's the key is A. If you can get A, then B, make sure you draw a lovely picture so you can show the reader you understand the question. Find your Z-scores, your observed minus expected in the numerator. And then go ahead and just calculate your answer with either your calculator or your table. Oh, I got to keep going. Okay, one last question. Lefties and multiple births came up in our other two presentations, and we have a really, really cool problem here with that same scenario, but a different question. Here we have a scenario where we have a region has a certain percent of multiple births. And then it says 2% of those who have multiple births are left-handed. And then among those who are a single birth, 11% are left-handed. Well, as soon as you read this type of question, and this is taking Mrs. Nataro's advice of just looking at these keywords, this conditional probability of among of this group of people, you have two strategies. And one is a table or a tree diagram. And I'm going to share with you the table. And because of our short amount of time that we have here today, you want to be able to, if you can fill out this table, you can pretty much answer any probability question possible. And here's we go. I'm going to start off with 100 people. If I have just 100 people, I don't need any formulas whatsoever to do this table. I'm going to start out with 3.5% or multiples. Therefore, 96.5 of the people, remaining 100 people, would be single births, singletons. Among the 3.5 people, 22% of them are left-handed. Therefore, the other ones are not left-handed. How do we do? Single birth. 11% of the single births are left-handed. The remaining are not. And if I fill these in, there's my totals. I need to be able to answer my questions, and I can answer everything from this table. In this case, left-handed, 11.4%. What's the probability of being a multiple given they're left-handed among the left-handers? Given the left-handers, we're focusing on this population. And we have this ratio. Again, I didn't use a single formula. I haven't used a single formula yet. Now, in our last 2 minutes, and I know when I promised you all I would be done at 8:30, so I will go quick on these last two. The last two was already shared, a binomial from before, but let me share with you, it's not going to come up 100 times, but a binomial is going to come up once somewhere on the test. So I want to remind you what a binomial is. This is exactly 3 children. Oh, this is at least 3 children. A very, very common answer is kids will just do the probability of exactly 3 children, not at least 3 children. So be careful. That at least words is a really important word. Don't forget the at least. Underline it so you don't forget. In this case, we did 3, 4, 5 or more. So I did 1 minus the probability of 0 plus 1 or the probability of 2. I did just try to remind you what 20 choose 2 could be. You could use the C terminology as well. Yes, we could use a tree diagram for that previous question as well. And the last one, and then I'm done. And this is just an add-on question. I just added this one on beyond the AP questions that you see there. And this is, if randomly selected, what's the probability the first 3 children who is left-handed is selected on the 3rd child? So let me repeat it again. Sorry. What is the probability of selecting the first child who is left-handed by the 3rd try? So in this case, you want to think of it as, lefty, yay, I'm done. Or right-handed, then lefty, done. Or right-handed, lefty, we got it. So in this case, you want to think of it, this is actually called a geometric. I'm sharing this with you because this has never come up as a free response question before, ever. But I feel like it's been a hot topic in the last few years. Then COVID happened, and then it really never happened. So I just wanted to share with you one last parting words, and then I'm going to say thank yous. And the parting words are this. This formula of a mean of a geometric, which is not a common topic in our curriculum, is in the formula sheet. So there's no need to memorize it. And the standard deviation is also in the formula sheet. So if they would ask you to apply it, there's no need, you can just refer to it. But it's nice to know the meaning. In this case, it takes about 8 people to select until you get, on average, until you get a left-hander. And the spread among all these possibilities until you get a left-hander is around 8.5, 8.2 people. Anyway, that's we covered a lot of probability there. So I hope you picked up on at least one little maybe attribute that you've forgotten. I wanted to take the time to thank you. Miss Nataro is going to send out actually a survey for you guys that's going to take 30 seconds. It literally has 3 questions on it. But if you don't mind completing this survey that Miss Nataro is going to push out in the stream, we want to wish you, before I push my song, I want to make sure the...
hold on. I'm trying to get this link. Hold on. I'll get it.
Wait, hold on till we get the link to you all.
Yeah. All right. I copied it and now it's pasted in the chat. There you go.
Awesome. Okay, we will push out this link to you all, or the video to you all in the next few days. Good luck on May the 4th, and
yes, may the 4th be with you. And the link, you might not see it in the chat because now there's all these thank yous in the chat. But the link is basically a short little survey letting us know what topics maybe you wish we had reviewed and which topic was most helpful for you. I know somebody already asked, are we going to have any more of these? Right now, this is the only one we had planned for this year. This is our first time doing a virtual review session in this way. And so yeah, it's right now this is the only one. I know everybody.
I would very much encourage students who want more, if you should probably have access to AP Classroom, and on AP Classroom there are AP dailies that go over many different topics that I've given to my students. So I encourage you to go to AP Classroom and look at the AP daily videos.
if anyone would like to stick around for a couple last minute questions, we will be online for another maybe 15, 20 minutes if anyone has any additional questions, and thank you for coming.
Yeah,
probability can be scary. Somebody says probability.
Yeah, I saw that.
Yep.
I got a couple thumbs up.
Yep.
That's the one that students always struggle with too, and that's okay.
Yep. But remember, on the free response question, you can still get some partial credit on that. So
I just got a direct message question, so I'll address it here. So someone asked, can I go over blocking versus stratifying quickly? So the similarity is that in blocking and in stratifying, and feel free to chime in if you say it differently than I do, ladies. Blocking and stratifying both acknowledge that there are differences within populations somehow. But in blocking, we are going to do separate experiments, perhaps a drug study where we'll do one experiment on female subjects and one on male subjects because we think they might respond differently to the drug. So we're going to remove them from the general experiment and have separate experiments. And we might show different responses that way. In a survey, stratifying means we acknowledge that groups might have differences, but we want to make sure they both get included. So if you think about classes at your school, we want to make sure ninth graders and 12th graders receive equal representation within a survey. So we'd make sure we had 25% of each, but we're only doing one survey. Anybody
Yeah,
want to add to that?
I think, is that okay if I add something and tell
Yeah,
me?
please do.
This
Yeah,
is
yeah.
how I sort of say, stratification is how you sample data, where blocking is for experimental design when you're designing an experiment.
But they do have a similar purpose in that you're concerned that there could be a difference because of that particular categorical variable, right? You're stratifying or you're blocking based on a categorical variable.
Yeah, their purpose is very similar.
So do you see either of you see any other questions that you might have gotten? I don't see any in the main chat, but I don't know if you ever got any more direct message questions.
No, I don't have any more.
Okay.
When to go over different tests? Is there a short answer to that? You got it.
I was gonna say, I like the stats medic flow chart.
Yeah.
In
general, so I'll go over some generalities and we can all chime in. In general, you're going to use Z for proportion questions. You're going to use T for means questions, and you're going to use chi-squared for categorical data. So if we're asking about M&M colors or Skittles colors, that'd be a chi-squared type of thing, or anything that's categorical within a table. But in general, Z is for proportions, T is for means. That's not the most elegant response, but the short version for what you need to know for AP Stat, that might be the.
Just to add to that, if you visually see a scatter plot, you're going linear regression. Like it's not categorical. Like people will say, oh, it's categorical. Well, do you visually see a scatter plot with this data? If you visually see a scatter plot, it's oh, nice. Yeah, thank you.
Thanks for sharing that.
Yeah.
It's linear regression.
So for those of you that are still here, feel free to take a screenshot if you know how to take a screenshot of that.
So Leigh, I'm going to address, I just saw something in the chat there. T for means if no population standard deviation is mentioned, right? There's no name there, it's just dashed. That is correct, but I'll also point out that if you know the population standard deviation, in theory, that would be a Z-test, but that is actually not content in AP statistics anymore. You're not required to know that difference. You would never be asked a question about an inference procedure for means that would require a Z. Up until a few years ago, they might have, but that's been removed. So I can say with safety that if something is going to be about means, a T is going to be used. You don't have to differentiate between whether you have the population standard deviation or not. Oh, this is a great question.
Yeah, definitely.
Who wants that last question?
I'll do that one. So how can you manage your time with the free response questions? Should you spend more or less time on certain questions? So generally speaking, I would say question 1 is kind of like a warm-up question. Not always, but generally speaking, right? It kind of gets you into taking the AP exam. You don't want to leave question 6 till the very end because the investigative task is weighted more than the other 5 questions. There was actually a couple of years where I would actually give my students a set of 6 questions, and I would have them read through all of them first, just skim through them and decide the order that they were going to go in the questions on. And very few students did the questions in the exact same order, right? Some people are like, you know what, I know that's a probability question. I know that one's going to be a little more challenging. I'll do that maybe second after I've done question number 1. So that if I get stuck on it, I can go back to it a little bit later on. But I don't want to leave that to the very end when I'm running out of time, because then I'm going to be more stressed. So it's really individualized, but definitely don't leave 6 till the very end, and don't leave that one blank because it is worth more. Do you have anything else to add about that, Bob?
Yeah, I'll add just to this. I do something similar to you, Leigh, where I tell students to just scan all the questions. I used to have students mark all the parts of questions with red light, green light, yellow light. And green light meant, okay, do it now because I know I can knock this one out of the park. But anything that was red light, anything that you thought, oh, I'm going to struggle with this, or this is going to really be a time suck for me, save it for the end. Because like Ms. Nataro said, you cannot leave yourself only 3 minutes to do question 6. You need to leave a good amount of time to explore question 6. You don't have to get a 4 in it, but you can't get a 0 on it. If it's a question that you plausibly can get a 2 on, that question 6, you need to grab that 2.
Yeah, I agree. I'm going to reiterate that. Wherever you are, you need 30 minutes for question 6. Like, just stop and do the 30 minutes.
Right.
But I think it's also good to know, like, the theme of the number of, like, the first one is a descriptive statistics question. No matter what, the first one's going to be a descriptive statistics. So it's fun to, like, buy into that and get your momentum. And then, then you're going to get into maybe a regression. And then the next one or two will be a probability, and then you'll get an inference. I mean, so it does sort of go in the flow of the course. Mm-hmm. So you can certainly pick and choose your battles, but you can't, I agree with both of you, you cannot skip number 6. Mm-hmm. And even if you don't know how to do part A of number 6, don't skip any part of number 6, because the last 2 could be fairly easy.
Yeah. Yep. There's another question there about PDF and CDFs that I think we can go over quickly. So PDF is for questions where you're trying to find an equals. If I'm going to find a probability X equals 3 in a binomial, and I'll be honest, I don't have my students use geometric PDF or CDF because I think geometrics can just be calculated without that command. I wouldn't stress myself out over that command. I see Beth nodding to that. But binomial, if I want to find the probability X is exactly 3, that is a PDF. If I want to find a probability that X is less than or greater than a value, that's a CDF. And then you have to make sure you know how to use your calculator for some of those CDFs, because there's cases where you might have to subtract as well, depending on which model calculator you have.
But a multiple choice question, you should know the format, because typically they don't even give a solution. They'll give it as a write-up of 5 choose 2 times whatever to the whatever.
Yeah. Yep, definitely be familiar with the formula.
Oh, and that's a formula sheet. That's right in the formula sheet. Mm-hmm. N choose X times P to the X times 1. So become comfortable with the things that are in your formula sheet that you feel like you just don't want to memorize. There's no reason to memorize. Mm-hmm.
There's some more great questions too. Dash asked again, are bell curves optional for things like hypothesis testing, state plan do? So a hypothesis testing question. I'll say in general, yes. I can't think of a time we've ever graded the bell curve. It's kind of nice, but it really, when you have to do an inference question, usually the mechanics are just the test statistic and the p-value. You don't even have to show a formula. We agree with that?
I would agree with that.
Yeah.
I would agree with that, but then my probability question was an example that you needed to show a direction to show knowledge of that. So yes, right. For an inference procedure, yes.
I would say if you are comfortable drawing pictures like that with the distributions and shading, and that's something that really helps you, then definitely do it, right? If that helps you and you're doing it right, then definitely do it, because I feel like sometimes when students shade and then maybe they look at their picture and like, oh, this should be less than 50%. I've only shaded a little bit of the tail. Why is my answer, 90%? And then they realize that they maybe had it in the wrong direction or something like that. So sometimes drawing that picture can actually help you identify a potential error that you might make.
Could be.
But I actually think all 3 of us are going to agree on, and everyone, what they said it is dead on, but all 3 of us are going to, don't write a formula.
Don't write a formula. Stop writing formulas.
Stop writing formulas.
Yeah, at this point, it's not worth your time.
Yeah.
There's the list, the pro-con list has more cons than pros. If you give us a formula, and this goes kind of Joelle's question, I think, things we look for. If you write a formula, we must check that formula. And we have to make sure you plugged in things correctly. And if you haven't, even if you have the correct p-value, then we have to ding you for the formula. So at this point in time, I know I have my students show formulas because, again, they come up with multiple choices sometimes. So respect the structure, but in the time construct of an exam, don't write the formula out.
Yep. Elizabeth's question, the only difference between geometric and binomial is that binomial have a fixed number of trials, and geometric doesn't. That's pretty much the big difference in terms of
a number of successes you're looking for within those trials, right?
Right.
Yeah, so very similar.
Yeah, but they both have a fixed probability. The trials are independent. Probability is the same from trial to trial, that sort of thing. So those things are the same.
Mm-hmm. And Joelle's question, what are some things we look for? Well, Joelle, keep in mind, we're handed a rubric. They tell us, here are things that we have to look for. And hopefully your teacher has exposed you to some of those rubrics during the year. But I would say being succinct and clear, and if the statistical reasoning is evident, then you're more likely, I don't want to say given a break, because we don't give people breaks. It's based on what the rubric says. But if we're kind of hemming and hawing about whether it seems like you have it right, we're more apt to give it if it sounds like you know what you're talking about and not using a lot of jargon and strange symbols. I don't know. I'm not quite sure how to answer that question.
I would say, make sure if you're having to write an explanation to something, compare and contrast the distributions, for example, do what you need to do and don't ramble on too much. They give you a lot of space for some of these questions. That doesn't mean you need to fill it, right? Just answer the question and move on.
I wanted to get back to the previous question, and I apologize, I didn't chime in earlier, about the binomial and the geometric. So I put my slides in the stream, but question my C and D. So the reason why I chose question C and D is because C is a binomial. C is 3 out of 20, like 3 successes out of the 20. So you're moving around. The 3 people could go anywhere. The 3 lefties could go anywhere you want. That's a binomial. Where question D is saying, what's the probability on the 3rd try, you're going to get the first lefty. That's a geometric, where the very, very last pick is a success.
Beth, I'll actually say I agree with you too about your thought about geometric. I mean, they did emphasize it within our changes to our curriculum, and it does feel like a geometric. I'm very bad at predicting what's going to be on the exam, but it does feel like, geometric might be due to slip in there somewhere. I don't know what you mean in the standard deviation, but it feels like it's kind of due to slip in there.
I think there definitely needs to be a geometric. If it's not on the free response, you're definitely going to see one on the multiple choice.
And I think it really could be a mean, and I think it could be interpreting the mean there.
Yeah, I can see that. Yeah, I can see that.
Here's an example right here, and that's why I put it down there, and that they're not memorizing. It's the theory behind this is the sum of a geometric, which they learn in algebra too, but I don't even go through that. Right. The truth is they need to understand what 8.7 represents.
Right. Cool.
All right. So it looks like we only have 15 people left, and 3 of those 15 people are us presenters. So I think we're done for this evening.
Yeah.
Thank you so much.